Good morning to all. Today we are going to see about mechanical properties of solids and fluids. Solids. A solid has a definite shape and size. If you stretch a helical spring by the gentle pulling in the end of the spring increases slightly. When you leave the ends, the spring regains its original shape, size and shape. Solids is the means of all particles are very closely packed. Mechanical properties of solids, intermolecular forces, elastic and plasticity, perfectly elastic body, Young's modulus, Poisson ratio, bulk modulus, likewise that. Intermolecular force. In solid atoms, molecules are arranged such a way is a molecule is each upon the forces due to the neighboring molecules. Elasticity. Elasticity is the body is gained the original shape and size. Then this force is removed, this is called elasticity. The change in the shape and size of body when external force and act is determined by the forces between its atoms or molecules. Plasticity. In the plasticity is the size and shape. Removal of the deforming of called plasticity. Such a body is called a plasticity. It's not a gain original size and shape. Perfectly elasticity body is the original configuration immediately and completely after the removal of the body. Example, quarters of the phase polar bronze. Young's modulus for solid in the form of wire and thin rod. Young's modulus, the elasticity with a elastic limit is defined as the ratio of longitudinal stress to strain. Poisson ratio. The ratio is determined the diameter del D to the original diameter D is called the lateral strain. The ratio of the change in length dl to the original length L is called the longitudinal strain. Bulk modulus. Within the elastic limit, the bulk modulus is defined the longitudinal stress and volumetric strain. Shear modulus or modulus of rigidity. It is definite the ratio of the tangential stress to the shear strain. Stress is defined as the ratio of the initial internal force of F produced when the substance is deformed. The area of the A over which is the force acts in equilibrium. This is force equal to magnetic to the externally applied force. Types of stress: normal stress, tangential stress, strain. It is defined as the ratio of the change in size or shape to the original size or shape. It has no dimension. Types of stress: longitudinal strain, volume strain, shear strain. Hooke's law, breaking stress. Hooke's law states that within the elastic limit, the ratio of the stress to the corresponding strain produced in the constant. This constant is called modulus of elasticity. Breaking stress, the ultimate tensile strength of the material is the stress required to the wire of the rod by pulling on it. The breaking stress this material is the maximum stress which a material can withstand. This properties of solids represent as Young's modulus, bulk modulus, modulus of rigidity, Poisson ratio, Hooke's law, stress and strain, application of elasticity and plasticity. Fluids. Fluids are the substance which can flow, liquids and gas. It not pauses define the shape. When an object is submerged in the liquid at rest, the fluid exerts a force in a surface. Normally, it is called a liquid. Examples: liquid and gas. Mechanical properties of fluids: pressure, equation of continuity, Brillouin theorem, viscosity, Stokes law, surface tension, angle of contact. Pressure. The thrust experiment per unit area of the surface of liquid is the rest is called pressure. When the liquid is equilibrium, the force acting on it is the surface perpendicular everywhere. The pressure is the same horizontal level. The pressure at any point in the liquid depends upon the depth below the surface density of liquid and acceleration due to gravity. Equation of continuity. According to the equation of continuity, if there is no fluid source or sink along the length of pipe, like A1, V1, rho 1 equal to A2, V2, rho 2. For incompressible liquid, rho 1 is equal to rho 2. Hence, the equation is given as A1, V1 is equal to A2, V2, where the cross section of the pipe is more. Then viscosity. Viscosity is the property of the fluid by virtue of which an internal frictional force comes into play when the fluid is in motion in form the layers having a relative motion. Stokes' law. According to Stokes' law, backward dropping force acting on the small spherical body of a radius or moving with a velocity v through the viscous medius of coefficient of viscosity eta is given as. It is the property of the liquid. Surface tension. Liquid as the rest tends to the minimum area as the such as behave as the stretched elasticity membranes. The force acting per unit length of line drawn the liquid surface. The SI unit of surface tension is Newton meter power minus 1, and dimensional formula is mt power minus 2. Angle of contact. The angle of contact, the tangent to the liquid surface at the point of contact makes with the solid surface inside the liquid called the angle of contact. This is the diagram of properties of fluids. Viscosity, Brillouin's theorem, pressure, surface tension, excess pressure in an air bubble, inside a soap bubble, inside a liquid drop. Thank you.